Okay, we're back, and Dr. Stein came in and totally messed up and erased
I did not mess up
She
anything.
did. She erased all my numbers.
I only erased some of the information.
She erased everything, and I had to redo everything. It's taken like 7 hours.
Well, Super Chicken, I think that maybe you need to think a little more fast on your feet. Oh, really? I'm leaving.
Okay, goodbye, Dr. Stein.
Good riddance.
Goodbye and good riddance. Okay, back to business. So these are 1, yes? Yes, we all know that. What's 284 divided by 21? That equals 13.5. Okay, 13.5 to 1 to 1 to, what's 55 divided by 21 equals 2.6. So is 13.5 to 1 to 1 to 2.6 anything close to 9 to 3 to 3 to 1? No. So anything that deviates from 9 to 3 to 3 to 1, this distinctly, that's right, hello, not even close. Nobody would argue with you that there's anything close to 9 to 3 to 3 to 1. You'd say these two genes, flower color and pollen shape, are linked. Okay? Linked. Because we know when we're actually counting individuals, if you go back to look at Chapter 3 and go through those numbers, they're not always exactly 9 to 3 to 3 to 1, right? It might be 9.2 to 3.1 to 2.9 to 0.9, right? But that's close to 9 to 3 to 3 to 1. How do you know if it's linked or not linked? Linked, close together on the same chromosome. Not linked, independently assorting, way far apart, or on separate chromosomes. If the numbers are pretty close, what about 10 to 4 to 2 to 1? Is that close enough to 9 to 3 to 3 to 1? We don't know. We're not able to make that judgment call. Okay, we're not expected to either. What we do is we're going to use statistics in order to let the numbers tell us, is it close enough to 9 to 3 to 3 to 1 to be independent assortment, or is it far enough away to be linkage? So that's what we're going to talk about next.
I just don't understand how that works.
Well, you shouldn't understand how that works yet, Super Chicken, because we haven't explained it. So hang on. Okay, so here's another example, right? Doing the same thing. This is from a different book, just showing you in a little bit different way how we want to analyze these numbers, right? That was the main idea on the screen before. Now this one's actually looking at them, okay? And these numbers are a little bit different, but it's the same idea, right? These aren't exactly the same numbers that were on the other slide, but close enough, but not 9 to 3 to 3 to 1. So these are the observed numbers, right? What is an observed number? What we see, what we get. This is what you get. You get what you get. Okay, that's what you actually counted in the experiment. Okay. You turn it into a ratio using, again, the lowest number. So 296 divided by 19 is 15.6. 19 divided by 19 is 1. 27 divided by 19, 1.4. 85 divided by 19, 4.5. This is your ratio of what you got. Okay? This is the ratio we would expect if not linked, right? Independent assortment, 9 to 3 to 3 to 1. So what would be the expected numbers we should get if it's 9 to 3 to 3 to 1? Well, we add up the total, okay, and then we take 9/16 of the total, 3/16, 3/16, 1/16. Okay, and do that math to figure out what our expected number is. Okay, so that means we'd expect 240, 80, 80, and 27. And then the statistics will help us compare these numbers to see if they're close enough to be called 9 to 3 to 3 to 1 or far enough away. But as you can see, this is kind of a pain in the butt. Figuring out what the 9 expected number is, the 3 expected, the 3, and the 1. This is not super simple math. It's not that hard, but it's kind of a pain in the butt, which is why we didn't do these chi-square analyses or look at goodness of fit in Chapter 3. We skipped that because I thought it was dumb, and I thought it was kind of just a bunch of mathematical gymnastics. So what we're going to do is we're going to do this linkage or not linkage in a much easier type of cross with much easier math, right? And so what we do is instead of doing a parental to an F1 to the F2 for this 9 to 3 to 3 to 1, we are going to do a test cross. Okay? We are going to test cross the F1 hybrid, so big P, big L, little l, times what? What is a test cross? Do you remember? Huh? Do ya? Do ya? Super Chicken? Do you remember? Okay, so he didn't remember, but we know the test cross is always to homozygous recessive. Okay? And so what is the ratio we would expect for independent assortment if we do that cross? This should be one of the ones we memorized back in Chapter 3, right? Here's a hint right here. Okay, right there. That's your hint.
I just don't understand how that works.
Okay, Super Chicken, I'll back up a little bit just for you. If you did the Punnett square, right? We only have to have one category for the test cross guy, because every single one of his gametes is going to be little p, little l. So then all we have to do is the big P's, the F1 parent. Okay, and so if we fill out this square, we'll see there's one of this type, one here, one here, one here. That's a 1 to 1 to 1 to 1 ratio. Okay, if you get this exact ratio, they're not linked. That means independent assortment. Right? Yes. Okay. If we have linkage, full 100% linkage, they're super close together on the same chromosome, they never, ever, 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 ever have crossing over happen between them, you'd get 2 to 0, 2 to 0. Okay? That means definite linkage. Anything in between that is some linkage. They're close together on the same chromosome, but crossing over does happen between them once in a while. Okay? And then that's where we need to use statistics to determine whether they're not linked or if we suspect linkage, okay? So that we don't have to go, ooh, is it close enough? I don't know. Is it big enough sample size? What should we do? Blah, 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 blah. Okay. This is just an example of the test cross. Do you understand where we are, Super Chicken? Okay, good. You're with us now. Right? The test crosses. In this case, they're setting them up like this rather than just showing it like this, right? So we can see which genes are on which chromosome, right? The homozygous dominant on one, homozygous recessive on the other, right? The test cross guy is always the homozygous recessive, and then what do we see in the offspring, right? All non-recombinant progeny, all parental. The half turned out like this, half turned out like that. That means what? Complete linkage. We did not get 1 to 1 to 1 to 1. What did we get? 1 to 1, right? 2 to 0 to 2 to 0. Does that make sense? Are you okay? Great. If they assort independently, they're on a different chromosome, or they're very, very far apart on the same chromosome, we get our 1 to 1 to 1 to 1. Ignore this screenshot and upload. That was only if we were in class. I will give you another assignment so you don't have to worry about that. Okay, so don't worry about that. Moving on, in case you didn't understand how crossing over can make recombinant, gametes. Here we are again with our chromosomes. We see crossing over happen, and we make recombinant gametes. Okay, so make sure you understand this, because that's the whole point of this. If no crossing over happened, right, they would all stay linked together. Crossing over happens, they appear to assort independently. The farther away they are, the closer they will look to independent assortment. Okay. So let's stop here and take a little break, and then we will come back for another lecture capture to do the statistics. I hope you enjoyed this, Super Chicken, and I hope everybody else enjoyed it also. Thank you very much, and I'll talk to you soon.